On a day in October 1942, in an improvised workshop shed near El Alamein, Egypt, a group of German military engineers worked around an American M for Sherman tank captured almost intact after a battle. The group included Lieutenant Colonel Eberhard Wolfram, armor specialist from the German Army Ordnance Office, and 3 civilian engineers who had been conscripted from positions in the German automobile and steel industries. They had spent 2 days systematically dismantling the Sherman, measuring, weighing, testing each component, photographing each mechanism. At the end of the 2nd day, Lieutenant Colonel Wolfram wrote in his field diary something that would appear in no official report. The men went silent for a long time after examining the engine and transmission. It was not the silence of men discovering technical superiority in the enemy. It was something different. It was the silence of men who suddenly understand a problem that has no solution with the resources available. 3,000 kilometers away, in Bavaria, Henschel's chief, Engineer Ernst Niekamp, was working on the final plans for a tank that the German industry had promised would be the definitive answer to growing Allied armored superiority. The Panzerkampfwagen weighed 2 tons, carry a version of the famous 88mm gun, and have 100mm frontal armor that promised to be impenetrable to Allied anti-tank guns available at that moment. It was an extraordinary feat of engineering, a monument to German technical skill, and the product of a manufacturing philosophy that had dominated German military industry since the war began. What Wolfram had seen in the Sherman, and what made him fall silent, had nothing to do with armor or firepower. It had to do with a completely different question that German engineers had rarely seriously considered until that moment. How do you manufacture the same object identically in 5 different factories located in 3 different states, using workers with different training levels, simultaneously, in sufficient volume to replace each unit destroyed in combat within days? The Sherman answered that question. The Tiger did not. This is the story of how German military engineers progressively understood that the war they were fighting would not be decided by which country could produce the best tank, but by which country could produce the right tank, in the right quantity, at the right moment, and how the gap between understanding this problem and being able to solve it was, for Germany, fatal. German technical supremacy in military engineering was not propaganda. It was documented reality across dozens of equipment categories during the war's early years. The Panzer for tank, in the G variant with its long 75mm gun introduced in 1942, was technically superior to the Sherman in armor penetration at medium distances. The Panther tank, introduced in 1943, was probably the most capable medium tank in the world during its period of mature production, with sloped armor that made it remarkably difficult to penetrate frontally and a gun capable of destroying any Allied armored vehicle at considerable distances. The Tiger was, in individual one-on-one combat, frequently invulnerable to anything the Allies could field until 1944. Stories of individual German tank feats are well documented and genuine. Master Sergeant Michael Wittmann destroyed 14 tanks and 15 personnel carriers in a matter of minutes during the Battle of Villers-Bocage in Normandy in June 1944, a feat that impressed even Allied officers who recognized in it a display of tanksmanship that few fighters in the world could equal. Lieutenant Ernst Bachmann Panzer blocked an American armored battalion's advance in August 1944 for hours, destroying 9 Shermans before withdrawing with his damaged tank. But Wittmann died in August 1944, and his Tiger was destroyed by Shermans. Bachmann survived the war, but the 9 Shermans he had destroyed were replaced within days. The systems the Allies had built to replace armored losses operated at a scale that made individual feats, however impressive, mathematically irrelevant to the final outcome. The German engineers in the Alamein shed in October 1942 had perceived something about the Sherman that didn't appear in combat reports comparing armor against armor and gun against gun, the Sherman was not a superbly designed tank. It was a superbly manufacturable tank. The Wright Continental R975. Engine equipping the Shermans, early versions, was derived from a widely produced civilian radial aircraft engine. Its components used tolerances that, by German fine engineering standards, were remarkably loose, acceptable within margins that a Krupp or Henschel engineer would have considered professionally offensive. But those loose tolerances had one direct consequence. Parts manufactured on a Ford assembly line in Michigan could be shipped to the field and installed in a damaged tank by a mechanic with 6 weeks of training. No part required individual fitting. None required a specialist. The Hotchkiss transmission system was equally revealing. It was not the most sophisticated in the world. It was the most standard. The same principles Henry Ford had applied to automobile production in the 1910s. Radical uniformity of components, elimination of all unnecessary variation, absolute priority to interchangeability had been applied to the Sherman with a rigor that determined every design choice from the start. Wolfram, in his notes, calculated that a damaged but recoverable Sherman could be returned to service in approximately 4 to 6 hours by a field maintenance team with standard equipment. An equivalently damaged Tiger required 12 to 24 hours. Heavy transmission specialists, and often parts that had to be ordered from factories and were unavailable in field depots. He published this calculation in no report, but he wrote it in his diary with a comment that needed no elaboration. "This is dangerous." Albert Speer, the architect Hitler had appointed Minister of Armaments in February 1942, understood the problem with exceptional clarity from the start of his tenure. In his memoirs written during the Nuremberg trials, Speer described a German military production system that had been built on premises that made sense when the war appeared it would be short, but that became increasingly dysfunctional as the war dragged on. The German armaments industry had been built around the same companies, the same engineers, and the same manufacturing philosophies that had produced Germany's elite industrial products in the preceding decades. Krupp, Rheinmetall. These were world-class precision engineering companies, and their military products reflected that heritage. Each Tiger tank took approximately 300,000 man-hours to manufacture. Each Panther required approximately 150,000. For comparison, each American Sherman required approximately 70,000, but man-hour figures were only part of the problem. The deeper problem was the structure of knowledge that German production required. A factory engineer responsible for manufacturing a Tiger needed a level of qualification that took years to develop. Tiger components were manufactured to tolerances requiring master metalworkers, precision technicians, and highly trained quality inspectors at every stage. When the war intensified Allied bombing of German industrial facilities and began killing and dispersing this specialized workforce, there was no way to quickly replace it. An agricultural worker conscripted for factory work could learn to install a Sherman component in weeks. He could not learn to manufacture a Tiger component in years. Speer tried to reform the system. His production rationalization program, initiated in 1942, generated real production increases that surprised even Hitler. Tank production doubled between 1942 and 1943, despite intensified bombing. But Speer's reforms met a structural limit that no administrative reorganization could overcome. German precision engineering culture was so deeply embedded at every level of the production process, in contract specifications, in quality standards, in union requirements, in designers' expectations, that any attempt at radical simplification was resisted at every step. Colonel Gerhard Group, who worked in the German Army's Armor Inspectorate and was extensively interrogated by American analysts after the war, described the tension with a frankness that the context of captivity made possible. When we tried to simplify the Tiger to increase production, Henschel's engineers told us the simplifications would compromise structural integrity or mechanical efficiency. And they were often right in terms of pure engineering. The simplified Tiger would be slightly less good than the complete Tiger. The problem is that the Americans weren't trying to make a tank slightly less good than the Sherman. They were making 49,000 Shermans, and we were making 1,347 Tigers. The figures Grupp mentioned, and which the American analysts interrogating him knew by heart, tell a story that no individual combat analysis can contradict. Between 1942 and 1945, the United States produced 49,234 M for Sherman tanks in their various variants. Britain produced an additional 5,100 Shermans in licensed factories. The Soviet Union, through the Lend-Lease program, received 4,102 additional American Shermans. The total Shermans produced and delivered to combat forces during the war exceeds 58,000 units. During the same period, Germany produced 1,347 Tiger I tanks, 489 Tiger II models, and 6,000 Panthers. The total of all German high-quality heavy and medium tanks, the machines critics use to argue. German technical superiority was approximately 8,500 units throughout the entire war. The ratio was not approximately 7-1 in the Allies' favor, as the raw numbers suggest. It was even more unfavorable for the Germans because Shermans could be quickly repaired in the field, while German tanks frequently could not. An American Army study found that approximately 70% of Shermans that were struck and damaged in combat in Europe were repaired and returned to service. The equivalent rate for damaged German tanks was estimated at approximately 45%, and even for those that were repaired. The average time out of service was considerably longer. British General Brian Horrocks, who commanded 30 armored corps during the Northwest European campaign, described the strategy Allied commanders developed for dealing with the individual superiority of German tanks in terms that the Germans themselves considered, retrospectively, one of the most lucid analyses of the problem. When we encountered a Tiger, Horrocks said the correct tactic was to envelop it. A Tiger could destroy a Sherman frontally at 1,500 meters. Most of us had enough Shermans to send at least 3 on the longer route while others engaged it frontally. Those 3 going around the long way reached positions where they could hit the Tiger from the side or rear, where its armor was vulnerable. It was wasteful of Shermans, but we had Shermans to waste. The Germans didn't have Tigers to waste. The story of Kurt Knispel illustrates the human paradox at the heart of this question. Knispel was an Austrian tanker who served in the German army and accumulated, throughout his combat career, 168 confirmed victories against enemy tanks, the largest confirmed number by any tanker in any army in the entire history of the conflict. He was exceptionally skilled, remarkably brave, and sufficiently unusual in his personal habits, refusing to wear his helmet in combat. Notoriously undisciplined with his superiors, maintaining friendships with prisoners of war against regulations to be treated as a tolerable eccentricity in light of his incomparable effectiveness. Knispel died in April 1945, 2 weeks before the war's end, near Brno, in what was then Czechoslovakia. His 168 destroyed tanks did not change the outcome of a single campaign. The tanks that replaced those he destroyed arrived at battlefields within days. The Allied tankers he killed were replaced by recruits who had completed 6 weeks of training. Knispel's own tanks, Tigers and Panthers that cost hundreds of thousands of specialized man-hours to manufacture, were irreplaceable at the speed the situation demanded. American Army Colonel John Alger, who wrote one of the most definitive studies on comparative tank effectiveness in Europe after the war, synthesized the Knispel paradox in terms that his contemporaries in the American armaments industry would have immediately recognized. Knispel was the finest tanker of the war. His individual skill was extraordinary, his courage indisputable, and his combat efficiency unparalleled on record. And none of it mattered to the final outcome. The system feeding him tanks and fuel and ammunition had no capacity to survive the system feeding his enemies. Individual excellence, however extreme, cannot compensate for systemic failure. The engineers, who dismantled the Sherman at Alamein in October 1942, continued their careers in different ways after the war. Wolfram, who had written in his diary about the silence that fell over the group after examining the engine and transmission, spent the years following the conflict working to rebuild the West German automobile industry. In an interview given to the Süddeutsche Zeitung in 1962, he was asked about the moment that had been most revealing to him during the war. Without hesitation, he mentioned that shed in Egypt. There was nothing extraordinary about the Sherman. He said, "It was a reasonable tank with reasonable armor and a reasonable gun. What was extraordinary was that it was exactly the same in every unit we examined. Every part of every Sherman we saw after that first one was interchangeable with it. We never achieved that. Every Tiger was slightly different from all the others, because each was built partly by hand. It was beautiful from an engineering standpoint, and it was a disaster from the standpoint of industrial warfare." The lesson Wolfram articulated in 1960, too, had been understood by engineers and economists well before the war's end. The problem was that understanding the problem does not automatically produce the capacity to solve it. German precision engineering culture had been built over generations. It could not be dismantled by ministerial decree, even with Speer in the reformers' role and Hitler impatient for results. The 1,347 Tigers and the 49,234 Shermans are, ultimately, numbers that summarize a philosophical problem as much as an industrial one. The Tiger was the product of a tradition that prioritized the excellence of the individual object. The Sherman was the product of a tradition that prioritized the excellence of the system. In peacetime, or in a short war, the excellence of the individual object can be decisive. Alamein fought on multiple fronts against adversaries with superior industrial capacity. Systemic excellence wins invariably. The German engineers at Alamein went silent for reasons their technical analyses fully justified. They had seen, in the zoomingly simple assembly of a mediocre American tank, the logic of a war Germany had no means of winning. Not because their engineers were inferior, clearly they were not, but because they were applying standards of excellence that were, for the specific purposes of this specific war, the wrong kind of excellence. The war was decided, in significant part, by that silence, and by the conclusions it revealed about the distance between what Germany could build and what it would have needed to build to survive. If you found this story as fascinating as we did, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. Leave a comment below telling us where you're watching from. Our community spans the globe, from veterans to history enthusiasts, and we'd love to hear from you. Thank you for watching.